Istanbul, Turkey. We have my good friend Jerry Medeiros this week in our session for the Next Gen Developer Forum session number 4. As you know, we are hosting our friends from all over the world for our series, which is mostly designated for junior developers and artists. And today we have Jerry with us, and he will present us, actually demo us a very nice VR bowling game within this session. Let's just know a little bit about Jerry. Jerry, can you just tell a little bit about yourself to us and to our viewers?
Sure. So, hello everyone. Thanks for having me today. Yeah, so I'm Jerry. I am here from Brazil in São Paulo. I currently work for Circuit Stream, a company that's based in Canada, and we basically deliver training and workshops. We basically teach people how to build VR, AR, mixed reality applications. I have a master's degree in computer science, but my background is all in game development. I have been like working with games for the past 10 years. And the last 3 4 years I changed a little bit to VR. So have been working with um like creating training simulation, not that much of the games anymore, but really I really love game development, so I'm excited to be here. And yeah, that's me.
Yeah, that's very cool, Jerry. Thank you very much for joining us today. You have actually just tried to squeeze this special session into your program. We are very glad for that. We really appreciate you taking your time for us. Actually, we can just start our demo if you are ready to go.
Sure. All right. So let's move things around here and share my screen. So today I would like to show you guys a little bit of what is possible to do in terms of VR using Unity and the XR Interaction Toolkit. So I will demonstrate how easy it is to make stuff. You don't need like lots of codings. It's basically a component-based system. So I'm pretty sure there's some pretty advanced people in Unity in there, but if you have never used Unity before, if you have never seen Unity before, this is how it looks like. It's a game engine. So basically we can create games or any other 3D real-time applications here. It's divided in a couple of panels. So we have here our scene, for example, where we can bring objects, cameras, lights, everything. Here in the bottom, I have the project where I can bring sounds, 3D models, textures, everything. So I will show you guys that I have some bowling assets here. So anything that you find on the internet, 3D models, or if you're an artist that you can module, you can just bring them here, like import FBX. You're gonna see all of them here in the project settings. And here we have the hierarchy. This is basically the same thing as we have here in the scene, but we see it in a different way. So here we see the objects themselves. For example, if I right click here and create a cube, I will be able to see the cube here in the scene and here in the hierarchy as well. So, oops, there's a bit of feedback there.
Yeah, I'm
Okay,
sorry for
cool.
that.
No, no worries. I think it's good. It's good now. Thanks. And and then now that I have this cube here, for example, I can see it in the scene. I can see it in the hierarchy. In the hierarchy, I can make like a parent-child relationship. So if I create, for example, a sphere, I can make this sphere child of the cube. And then if I move the cube, the sphere moves together. So basically, we can organize our objects and have like some 3D transformations applied to the parents and children there. So just a context for the ones that have never seen Unity before. And now we can get started. So basically, I would like to show you guys how to make a VR bowling game. So we need to have like a bowling ball that we can throw away and it's gonna like hit the pins and make them fall. So this is a little bit based on physics. We need to get to understand how to implement physics in Unity. It's quite easy. So let's start by dragging our assets here. So I'm gonna get this track. This is gonna be the basis for our bowling game. So I'm gonna basically be launching the ball from here in this direction. If you don't have this asset there and you want to try it, you can just like create a plane, for example. So right click in the hierarchy, 3D object, and then plane, and you can make this your track. Like you can follow the same steps in just this plane, but just to look a little bit nicer, I will use this assets that I imported here. You can find them for free on the internet. Quite easy to find them on Sketchfab or the asset store. And then I also drag the ball, make sure it is more or less aligned with the tracking there. So now I have this ball. If you don't have the ball there, you can use a sphere. So right click, 3D object, sphere. It's basically the same. You can play around with scale. So here in the left, we have those tools to make it bigger or smaller, but I'm gonna be using this ball. So this is the first thing. Now, if I wanna test my game, I can just hit play, and you're gonna see that we have two different views here. So we have the scene where we were playing our stuff, and when I hit play, it's gonna move me to a different view, which is the game. So this is basically what our end user is gonna see, and this is what the camera is rendering. So we can see that my camera is really far away from everything. That's basically why it's not rendering anything. It's just like rendering the sky. So I will move the camera a little bit closer to this set here, and I will probably rotate this camera around. You can use here the inspector to move that like exact numbers as well, instead of just trying to find what works fine. You can just use the numbers as well. And now there we go. I have here something that I can see in the game. The ball is here, the track is here, the camera is positioned. So now when I hit play, it's gonna automatically move me to the game view, and nothing happens. This ball is not falling. Basically, nothing happens there. This is because I didn't tell that I want a physics behavior in this ball. So I will select the ball and add one component that's called a rigid body. So in Unity, every time that we want something to react to physics, we just add a rigid body to it. And we can play around with mass, drag, gravity, all of those things. But just if I hit play now, look at what happens there. My ball falls. It's just falling forever and ever. So if I try to see what it is, you can see that the Y is just like decreasing every frame because the ball is falling forever. So if we want to avoid this ball from falling, we need to say that this ball can collide with things. So I will select this ball and add one more component that is called the collider. So we have lots of different types of colliders. One is called the sphere collider, and it's just basically this green outline here that is gonna tell me the shape of the collision of this ball. So now this ball can collide, and I also need to add it to the track as well. So if you want like two objects to collide against each other, both of them need to have a collider. In this case, I'm not gonna use a sphere collider because this doesn't look like a sphere. It looks more like a box. So I just add a box collider, and you can see that now we have this green outline here. And now when I hit play, what's gonna happen? My ball falls and it doesn't go through the track anymore. If I incline this track a little bit, like just do something like this, you're gonna see that the ball is probably gonna roll because now there's physics acting up on there. So this is basically halfway done. For the pins, we need to do basically the same. Like I can drag my pins here. I can position them wherever I want it to be. And we need to have the same component. So I want this to be hit by stuff. So I need to add a rigid body to them. So now they react to physics. And I also want to add a collider here. So we can see that this guy, it's not a sphere, it's not a box. It's more like a specific shape. So there are two alternatives here. The first one is using a mesh collider. So a mesh collider is going to use the same mesh of the pin, like the same 3D model here as the collision. But this is a little bit expensive. Like this takes lots of resource. So usually we try to use something that looks like this. And in this case, we can use, for example, a capsule collider. So a capsule collider is not perfect. You can see that it's not perfect. Like it's gonna, if the ball hits like this portion here, it's gonna already make the pin fall. But most of the times it's okay. It's just like a simplification that is acceptable. If it's not acceptable, you can just use the mesh collider and monitor the performance there. So now I'm just duplicating Control D or Control C, Control V, and adding a couple more pins. Pretty sure this is not the number of pins in a bowling game, but just for today, this should be fine. And there we go. So now I have the ball here. I have the pins there. I have the track. The physics is set. And now, well, I promised a VR game. So this is not VR, right? We need to make this VR. So let's get into it. First thing, when we are dealing with VR, we probably, or most of the times, we need to have like a headset or something where we have the lenses and it's going to be rendered here. So VR basically replaces reality completely. I'm going to be seeing just what is in this virtual scene here, not the real world anymore. So instead of this simple camera, we need to have something that can represent my device. So we're going to be working today with one toolkit in Unity that's called the XR Interaction Toolkit. It's basically a component-based event system that was made for AR and VR, and it makes our life a lot easier when we are working with VR applications, AR applications. So we need to import that into our project. For that, I'm going to go to Window, Packed Manager, and then here in the Packed Manager, we can search for packets. So here it's listing only the packets in my project. I can list all of the Unity projects there and then search for the XR Interaction Toolkit. By default, it's not going to show just because right now the XR Interaction Toolkit is under preview. It means that Unity is almost releasing it, but they're still working on that. So you need to enable preview packets. Just click here on the gear and then advanced project settings. It's going to open one more window. And then there is this property here, enable preview packets. And we click on this. I understand. It's going to, that I understand. It was just like, okay, I know that this is not completely ready, but I trust it's good. And now we can go back here to the package manager and search for XR Interaction Toolkit. The XR Interaction Toolkit. There we go. So this is the guy that we're going to be using. I'll just hit install here and wait for it to install. It should be just a couple of seconds. Let's see.
Jerry, when do you expect this package to be released actually? Is
Oh,
there any date on that?
That's a good question. No, there's no dates. Actually, they have been polishing that for a while, but I expect it to be really soon because right now, if you see here, it's 1.0.0 pre-4. So pre is a pre-release. It's the fourth pre-release version. They have been trying that. So it should be out soon. But right now, it's pretty stable. Like I have been using it for 1 year, I think, maybe more, a little bit more, and it's improving steadily and it's quite stable now. I'm comfortable using that even in professional projects already.
Oh,
It
really?
changed
That's
a
great.
lot between like when they released it and now. Like they keep changing the number of the name of the methods, deprecating stuff. So it was quite like a weird situation where because it was preview, they were just basically like changing stuff based on feedback. But right now it's quite stable and I don't think it's going to change a lot more. It's already, and this comes to this thing, like it's just like requesting that I enable the new input system. I will say yes. So this is a good thing. When they released the XR Interaction Toolkit, it was not prepared for the new input system in Unity. I'm going to show you guys the new input system in a while, but now it is. So it works with the new input system or with the old one as well. So it's pretty ready. It's quite cool. But there's no like specific date, but it should be soon.
Okay. Now we are going to use the new input system with this toolkit, right?
Exactly.
Yeah, that's
Yeah.
great. There is
Yeah.
one more
Because
thing we will learn today besides creating an XR or VR bowling game. Yeah. I think most of us do not have any idea about the new input system. We keep using the old one because it's
Oh,
easy. We are we are used to using that, and it does not create any problems for us. So
uh-huh.
until it is deprecated, we are going to use that. I think so.
Yeah, it's probably gonna be deprecated at some point.
Yeah.
I really like the new input system, and it's the same thing. Like when I started using it, it was really cranky. Like they were working on that and lots of problems. But right now, I feel like it's good. Like it's really interesting the way it works. The most like important thing about the new input system is that it's really it's action based. So you can say, for example, fire. Fire is an action. What
Mhm.
triggers fire? Well, I say so in the VR is trigger, in the keyboard
Mhm.
is enter. So you can have like multiple inputs for one same action, and then in the game you just like say this is the action, and then you can change the input outside of your code. So you just like organize the things in a better way. I really like the way it works. It's quite similar to the way Unreal Engine does that. Like in Unreal Engine, it's pretty similar the way you set up the inputs. So now
Yeah.
it's more organized. You don't need to go to your code and say get input with the specific name, and then you don't have like the code for the input tied it together with your action. So it basically allows you to separate those two things, which is really good.
Yeah, that's great. It works great with the code separation, right?
Yeah, yeah.
Yeah, yeah, that's great.
Nice. So here now we have almost everything that we need. So the last thing here that we need is to enable the plugin. So another good thing about Unity is that you can make this game here work on multiple VR devices. So it can be the Oculus, Vive, Index, and you don't need to change your code that much. You just need to enable the providers. So I'm gonna go here to File, Build Settings. Oh, it's not Build Settings. It's actually Edit, Project Settings, and then here we have the XR plugin management. So this guy, and I will need to install it. It's a plugin that allows us to determine which platforms I want to run my application at. So we can, for example, say, okay, I want to run it at Oculus, but also on any OpenXR enabled devices. So you can write your code only once. The interaction toolkit is going to use the plugin management to talk to the native plugin, and then it works on the device. So now we can see here, for example, I can just enable Oculus, and it's going to install the plugins that are specific for Oculus here. So if
Oh,
I
that's
click,
great.
for example, Windows Mixed Reality, it's going to install the package for Windows Mixed Reality. And if I click Magic Leap, HoloLens, well, Windows Mixed Reality is the HoloLens, right? But you can like just define which ones you're going to be using, and the plugins are there. You don't need to care about it that much.
Oh, that's great. If I'm not remembering it wrong, beforehand we were dealing with these settings issues inside the player settings part of the build settings, right?
Oh yeah,
It
that's
was
the
over there. So
yeah,
yeah, yeah,
that's not there anymore. So you used to do that here in player, right? And there was
yeah,
an XR enabled here.
yeah,
So
yeah.
they removed that in 2020 onwards. So they deprecated that in 2019, and now from 2020 onwards, you need to use the XR plugin management, which is a lot
That's
better.
cool. Yeah, it looks cool. Yeah.
Yeah. So even for mobile devices, for example, well, I will at some point build this to Oculus, so I can just like enable Oculus here. But you can also like when you're making AR, you can enable AR Core for Android, AR Kit for iOS when you have like AR Foundation. So you do everything from here. You just like define all of your plugins from here.
Super. That's great.
Cool. Now that we have everything set up, XR Interaction Toolkit is installed. XR plugin management is installed. Oculus is enabled because today I'm gonna be building that to the Oculus, or at least like showing that in the Oculus. Now we can start making this a VR game. So the first thing, as I mentioned in the beginning, I will need to remove this main camera. Like this main camera doesn't make sense here because this is a virtual camera, but I need a camera that represents my device. So I will remove this one. I'll get rid of this one. Now, if I go to the game, it just says no cameras because we need to have at least one. And the camera that I'm going to be adding it's gonna go from the XR interaction toolkit. So I right click here, XR, and then I have here XR rig action based. This is the guide that I'm going to be using. So XR rig is basically a setup that represents the player in the real world with the devices that the player is using into the the scene. It says action based here because it still allows you to add an XR rig that is based on the old input system. No. Oh, device based. So this is the old input systems, but they're probably going to deprecate this. So now we're going to be using this XR rig action based. So now when I add this guy, you can see that there's a new camera here. It just like added a new camera. So this green bounding box here is basically the representation of where my player starts. So it's basically when I jump into VR, my starting point. So I'm going to be starting from here. I can see that this is probably good. Usually we align this base here, this the base of the green bounding to the ground. So this is gonna represent the ground. It's basically where I am grounded there. And if we inspect the XR rig, it's gonna be a complex hierarchy here. So there are a bunch of things. The first one in the XR rig is basically like how it's gonna track the device, if it's based on the device itself or on the floor. So this depends a little bit on the device that you are using. So for example, most of the times for the new devices, you can use floor because the Vive, for example, it comes with sensors like positional tracking sensors that know where the floor is because you calibrate that. And in the Oculus Quest, you set up a guardian, like you define, they ask you to put your controller on the ground so they can measure where the ground is. So most of the new devices, you can just use floor as the tracking mode. For the old ones, like the ones that are that only have 3 degrees of freedom, like they don't know if you're moving, they just know if you're rotating the head. So in that case, most of the times you're going to use device, but those devices are almost non-existent anymore. Like the Oculus Go, for example, it doesn't exist. Almost nobody's using like Google Cardboards anymore. So most of the times floor is going to be fine. And then here, as a child of the XR rig, we have this hierarchy with the camera offset here, but the important objects are the camera and the controllers. So this main camera, it is basically very similar to the other one. It renders stuff, but it comes with this tracked pose driver component here. So this guy is basically who is determining where your device is and translating that position to the virtual camera. So by default, it tracks rotation and position. That's what we want, right? If I move forward, I want my camera to move. If I rotate, I want it to move to rotate as well. Depending on what you're building, maybe you want only rotation or only position, but most common is just using rotation and position. And now if I just hit play here, probably if Oculus doesn't trick me, and most of the time it does, I'm gonna be in VR. So now I'm here. So let me add the maximize on play here so you guys can see it better. There we go. So now you guys can see I am in VR. You can see that I can see the pins in there. I can see the ball in there. Everything looks good. But if I get the controller is not tracked yet. We need to adjust some stuff. But for the camera, it's already rendering. And I am there. I am here in VR. So now what's happening here is this component, the tracked pose driver, is detecting where this thing is and replicating that to the virtual camera that is here under the XR rig. That's basically it. All good. Does it make sense?
Yeah, yeah. Actually, we can understand that this is very different from creating a 3D game, because at least in my conventional thinking, I was supposing that the camera should be around the eyesight of the player or something like that, but we placed it on the ground. It's really different. Yeah.
Oh, oh yeah. And actually, what we placed on the ground was this base here. But
Hmm.
actually, there is this camera offset. This guy's gonna move up to the level of the ice. But this is based on my height, right? We cannot predict where it is. So that's
Hmm.
why we have this tracking here. Because this thing, this track, is gonna move the camera offset to the height of
Okay.
the
It's related to referencing the floor, right? Okay.
yeah,
All
yeah,
right.
yeah, yeah,
Okay.
yeah.
All right.
Exactly.
I got that right now. Okay. Thank you very much, Jerry. Okay.
Yeah, it's referencing the floor, but it's actually
Uh,
gonna move this offset. You can see
all
that there
right.
is like this representation of the player here,
Yeah.
but this is adjusted automatically based on your device. Like we cannot predict. So this is one of the main differences when we are building a regular 3D game and a VR game, for example. In a 3D game, we have total control of the camera. So you know exactly what the player is seeing at every time. So you can, for example, fake some spaces, but in VR that is a little bit more tricky because the user can move the camera wherever they want to move. So you need to be more careful.
Yeah. You have to strap him down. Okay.
Yeah, you need to be a little bit more careful because otherwise, yeah, you're gonna have problems there. The player is free, right? They can move, they can walk
Yeah.
around, they can go wherever they want to go. So yeah, so now we need to make the left hand controller and the right hand controller work. So one thing that is really important in the XR interaction toolkit, it is based on two simple concepts. One is interactor, anything that you can use to interact with stuff. And the other one is the interactable, anything that you can interact with. So for example, the controller here is gonna have XR ray interactor. So it's just like that one that draws a ray and you can use this ray to interact with stuff. There is another one, there is the direct interactor. So you need to touch stuff. So everything that can be used to interact is an interactor. Everything that you interact with is an interactable. And to make those two communicate, you need to have this interaction manager. So you don't need to change this guy. It just needs to come here. But you're always going to see that it's added automatically to
Like
your
the event system of the
huh?
UI.
Yeah,
UI.
like the event system of the UI. Exactly. It's just here, it's standing there. What it's doing is just like, well, this interactor interactive with this interactable and make them communicate. So you need to have that just in case. Well, you need to have that in the scene. If you remove it, it's going to stop working. You can see that here in the right hand controller, for example, uh, it does have a reference to the interaction manager. Like every single interactor, every single interactable are gonna request a reference to the interaction manager. So it's basically like just the glue in between those two types of components. So we have two components here. We have this XR ray interactor that is just the line that we're gonna be using to interact, and we have the controller. So this is the one that is gonna where we need the new input system. So you can see here that it requests actions. What is the position action? What is the action that makes the position of the controller change? What is the rotation action? What makes the rotation of the controller change? And then we have the actions that are more interesting, like the select, activate, UI press, haptic, and so on and so forth. So select, for example, can be the grip button, and activate can be the trigger. So you can determine what those things are. So usually you can go direct here and add a binding manually, but this is terrible because you cannot reuse the binding. So usually what we do is just create in the new input system. We right click here and we create a new, what is it? What is it? XR, no, it's not XR. Animation controller, legacy. Input actions. So here, this input actions is basically your action mappings. So input actions. Let me create one here. And then when you double click it, it's gonna look something like this. So you have here the action mappings. You can have, for example, mapping for right hand, mapping for head, mapping for left hand, or you can have mapping for like running, flying. I don't know. It depends on your game. So you can have like multiple mappings here. So let me call this, for example, right hand. And then you can add different actions. So you can name them, for example, select, like, oops, select. So this is my select action. And then here we need to add the bindings. What do I want to use for selecting? Um, I can select here, for example, I can just go here and select like what is the type of controller. So say, for example, I want for selecting with the mouse to be a press. So I can just use like now every time that I press the mouse, it's gonna trigger the select action. You can add more. That's what I was telling. Like you can make it work for multiple devices. So in the device that I have here, like this Oculus controller, I can just go here and select, for example, XR controller right hand, optional controls, and then I can select, for example, let's see, grip pressed. So now grip pressed is this guy here. It's gonna trigger the same select action. So you can build here all of your actions with the bindings that you want them to have and just drag them to your controllers. I would need to do it for every single button here. Fortunately, Unity did that for us. So I just would like to show you guys how to create this from scratch. But in the XR Interaction Toolkit, if you go here to Window, Packed Manager, and then you select the XR Interaction Toolkit again, we're gonna have those samples. So one of those samples is the default input actions. If we import this is amazing. This is really good. We're gonna see here under samples that they created that action for us. So here you're gonna see that they created for the head and for the hands. For the hands, for example, the position is tracking the position of the device, and so on and so forth. The select, for example, is the grip press. The activate is the trigger press. So they just created all of those for us. So we don't need to go over them, but you can just modify them if you feel like. So usually I start using this because it's already there, it's done, and then that's it. I just modify the ones that I want to modify. So now that we have this guy, we can go back to our right hand and just tell them to use this. So Unity is so amazing sometimes that by default, the way I would need to do it is just like click here on use reference and then find the one for position for the right hand and add that for each one of those. But just to make our life easier, Unity created here some presets. So you can see here this right hand controller preset. I can just like get rid of this controller, remove controller, and drag this preset here. So this guy is the same thing, but all of the actions are already assigned. So we don't need to assign one by one. And there we go. So I basically
We
have
would
it.
like to thank our good friends at Unity, right?
Yeah, this is so cool because this process is amazing. Like when you set up this, you have this working for multiple devices and it's easy to change, but it's quite boring like to do this one by one. So someone did that for us and we can thank them for that.
Jerry, by the way, there is a question on the chat board. If you'd like to attend to that.
Oh, sure. Let me see. There was a rendering type in main camera right under where can choose rotation and transition. Right now it's before and after update, I guess. What are the other types and how do they affect the game? I mean, what is the purpose of different types except performance? This is a really good question. This is a really, really good question. So what they're mentioning is this here. In the track post driver, we have this update type and we can select update, before update, or update and before render. Oh, update, before render, or both. So what is this? If you guys are not super familiar with Unity, every object in Unity, there is a life cycle. So there are some functions that are called in order. So the first one is the awake. It's called only once. Then you have the start. It's called only once. Then you have the update. It's called every frame. Then you have on before render. Then you have render. So they run in order. This here is to tell when Unity should be updating the position of the controller, or in this case, the position of the headset. We are telling them to update it twice. One before on the update, like on the update loop, and before you render to update that position again. So you mentioned that performance. So yeah, this is more it requests more from the processor, so it's gonna impact on performance. But for VR, this is really, really important because you probably have heard about people that have motion sickness in VR, right? Like people that are playing and then get some motion sickness. There are a bunch of reasons for that, but the main reason is what we call visual vestibular mismatch. It's like our brain is perceiving movement in a way that our eyes are not seeing. So if there is lag, any kind of lag, our brain says, no, this is not good. I'm gonna be sick. It's basically like when you're in a boat, for example, that people feel some sickness. This is because we're feeling the motion but not seeing it. So your brain is like, there's something weird here. In VR, that's really common. So we need to make sure that we update things as much as we can so there is no latency, there's no lag. Usually it starts to get comfortable at like 70 frames per second, but the target's at least like 90 frames per second. This is why the new Oculus Quest with like more with the how is it called, like the frequency that the screen can update like to 160 hertz, they are 120 hertz, they are improving that because if you can update the visuals more often and you can like improve the performance so you have less lag, like your frame rate doesn't drop, that's better for the comfort. So in games we can accept some drops to frame rate like 30 frames per sec, 45 frames per second, maybe that's okay. But in VR, that's really problematic because the first problem is this, like visual. Oops. Oh no. My Oculus just fell. Visual vestibular mismatch. Like I'm seeing this, but it's not updating. So that's really uncomfortable. And if there is any lag, your brain is just going to be like, no, this is not good. So that's why by default, we use here update and before render. So I'm just telling this, okay, we're going to update the position twice. One in the update, and then if needed again before I draw. So I make sure that the position, what I'm seeing is exactly aligned. What I'm seeing in the virtual scene is aligned to my eyes here. So that's basically it. It impacts on performance, but it increases the comfort of the user. This is one thing that we need to care about a lot in VR that in regular games not we need to, but like in different aspects, right?
Yeah, it's really difficult to compensate for the latency in VR, right? Therefore, we have to be very careful with such issues. Yeah.
Exactly. We need to, yeah, exactly. Like the latency is gonna make your user feel really sick. So
Yeah,
you
yeah.
do need to care about that. Optimized, have like a really high frame rate is especially important in VR. It's more important in VR than any other type of games because it can cause discomfort to the point that the people is not gonna be able to play. Like they're gonna feel motion sickness.
Yeah.
Cool. Cool. But that's a really good question. And okay, so I did that for the right hand. You can see here that now I have all of those actions set up. And now there's one last thing that we need to do, that because I'm using that reference, I'm using this input actions here, this new input system, I need to tell my scene that this is the one I'm using. So we need to create one component here that is called the input action manager. It doesn't need to be in the same place where the XR interaction manager is. It can be anywhere, but usually I just place it here so all of the managers are in the same place. And it can take a list of input actions, and I would just drag these input actions that we are using here. So if you have more, like for different devices or wherever you have there, you can just like add more to this list. In our case, we just need one. So this is mandatory. It needs to live here, same as the XR interaction manager. When you're using the new input system, you need to have this action manager here just to make sure it works. So now if I hit play, and I hope my device didn't disconnect, it probably did. Let me see if I can get to it real quick here again. Oculus link. Oculus link. There we go. You're gonna see that now possibly my controller is gonna be tracked as well. Um, let's see. I'll hit play and hope it works. There we go. So now you can see that my controller is tracked. And because I have this ray interactor, it's just like drawing a ray that comes out of my controller here. There we go. So now it tracks not only the hand, but also the controller. You can customize those colors. So here, for example, in the right hand controller, we have this XR interactive line visual. So you can change, for example, the valid color, the invalid color. The invalid color is when I'm pointing to something that cannot be interacted with. And the valid one is when I am pointing to something that I can interact with. It's possible to change like the format of the line as well. Here, for example, it's a straight line. So for interfaces, usually a straight line is good. But for teleportation, we usually prefer a curve. So we know exactly where you're going to land. So all of those things are here out of the box. You don't need to implement them. And for me to be able to grab the ball here, I need to make it an interactable. Remember that we have the interactors already, like the controllers are the interactor. Now we need to have the interactables. I'm just going to select the ball and add a component to it that is called the XR grab interactable. So now I'm just saying, well, this ball can be grabbed. And it can change a bunch of things here. For example, if when we are throwing, if it's going to detach, how is the force that we are like launching it? So we can add like an angular velocity when we are throwing it. We can make it like more realistic, just adjusting the parameters in general here. But now probably if I point to it and use the select button, which in our action manager is the grip, I can just point there, press the grip, and now it's here in my hand. And I can throw it. Let me see if I'm gonna hit the thing there. There we go. I can hit it.
That's great.
Yeah. So of course, most of the times we don't want to use like this ray to grab the ball. It doesn't make that much of sense. But because I don't have space here, I'm using that. If you don't want it, you really want the person to grab the ball, what you need to do is just here, instead of this ray interactor, you're gonna be using a direct interactor. So a direct interactor is another interactor, but you need to touch. You don't have this ray coming out of there. So those are the only two interactors that exist right now in the XR interaction toolkit. By default, the default interactor and the direct interactor and the ray interactor, those are the only ones. But all of those classes, if you guys know how to program and are comfortable with C#, they are, you can extend from them. So you can create your own interactors and your own interactables. So for example, this grab interactor here, what is it? It's in the ball. You can inherit from this class, grab interactable, and add more behaviors there. And you're gonna have everything that is already there. And another thing that is super cool. There are lots of events that are dispatched. So in the XR interaction toolkit. So for example, here, when I hover, exit, when I select, when I activate. So those events can be called like to play a sound or to, well, do whatever you want to do. So you can just like add an object here. Say, for example, this doesn't make any sense, but let me show you something. For example, when I select, I want to turn off the sun, for example. I'm going to get the directional light here, light, and I'll set the intensity to 0. It doesn't make any sense, but just to demonstrate that you can like change when the XR interaction toolkit events happen, you can call anything, code or any other thing. So now it's probably going to get dark. There we go. So now it's darker because I just turned off the directional light when I grab the thing.
Very useful callbacks. Yeah, you can use it for everything. That's great.
Yeah, and you have callbacks on the interactables like here, and also on the interactors. So here in the controller, if you select the interactor, you also have the events. So you know, for example, when this interactor hovers something or selected something or exit something. So it's called on both ways. And another cool thing, you can add audio events by default with no code. So once selected, for example, you can just drag a clip here and it's going to play it. You don't need to implement anything. And the most impressive thing, the haptics.
Haptic event.
So when I select something, for example, I can just make it vibrate. So you
Yeah.
can determine in how long it's going to vibrate in seconds. So like for 1 second, and what is the intensity. So now, well, you guys are not going to be able to probably like feel it or anything, maybe the sound. But now when I grab, it's just gonna vibrate. Probably you cannot hear the vibration there, but it does vibrate. So you can play around with the haptics here with no yeah, we know code as well. So so yeah, that's I think that's it. Like now we have under a couple of minutes. I know well, under a couple of minutes, like a game or a basis of this game, and you guys can extend from there and play around from there. And that's it. I hope it was
Yeah.
useful somehow.
That's great. Yeah, thank you very much, Jerry. Yeah. Personally, I never tried VR, AR, or XR in general beforehand, and that was a great session actually. And I learned that Unity has been providing us with this XR toolkit for some time right now, and we can actually create our own VR games, at least the simple ones, very easily within Unity. That's great, actually. Very good news for those who are interested in XR applications. Actually, that was very powerful. Yeah,
Cool, great.
I would like to try that out by myself, but I need to set beforehand, right? I don't know
Yeah.
how to do that, but I need a set, at least one set. It should be one of those new generation devices, right?
Yeah.
Otherwise, it won't make much sense for us, like the cardboard, Google Cardboard or
No, even
something.
for the it supports even the cardboard.
Really? Oh,
Yeah,
that's
the
great.
difference is that in the cardboard you don't have 6 degrees of freedom, just three. So it doesn't know if we're moving, just rotating. But that's definitely possible. You can do that for the cardboard as well. The problem with
Yeah.
it's not a problem, but for the cardboard, you're not gonna have this motion controller. So your hand is not gonna be moved this way. You need to figure
Mhm.
out a different interface. But for the visualization, you can actually use a cardboard. That works.
Yeah, that's great. Yeah, I didn't know that, and it's really interesting to know that we can actually create different types of XR applications for so much of a different devices with actually almost no code over here. With this toolkit, it's possible to do that without any code. It's really amazing. The guys at Unity should create something like that for other types of stuff like the 3D games or 2D games. Actually, I'm jealous of you right now. That's great. Yeah. Thank you
Yeah,
so
it's
much, Jerry. I don't know if you have any questions, guys, over there. If you like to ask Jerry, please just use the chat board, or you can use your microphones. Uh, I don't know if you have tried anything in XR beforehand, but that was really cool. Okay, I see that there is no question over here. Actually, that's really cool. All right, I think everybody would like to try this sample application on their own for some time. Maybe we can actually just invite Jerry for another session to make go over your own creations with him. He can just describe whether you have created something cool or not.
sure,
This is possible actually. Yeah, I would
sure.
like to thank you, Jerry, so much for taking your time to be with us today. That was very cool, actually. I'm personally very grateful for you because you didn't ask for much beforehand. You just said that it's okay, we can do anything you wish. And this was really fun for us. Yeah, I would like to thank you. I would like to thank you again on behalf of our friends over here. Uh,
Great.
if you have any time in the next couple of months, we will be very glad to have you again with us. Actually, we can talk about that, of course.
Sure.
Thank you so much, Jerry.
All right.
Please take care of yourself. And I would like to say to our viewers that we will not be having any sessions in the next couple of weeks because of the national holidays, and then we will have another experienced seasoned developer in a couple of weeks. After that, probably at the end of the July, and we will try to create more cool stuff with them again. Okay. Thank you very much, Jerry.
All right.
Please
Great.
take care
Thanks for
of
having me.
yourself.
Have a great night there. See
You
you
too.
guys.
Have a nice day. Bye bye.
Bye.